Hello learners, welcome to yet another session of RDBMS, that is Relational Database Management System. This is a brief outline of this module. In this module, we would be covering components of database management system, types of DBMS, logical architecture of DBMS, physical architecture of DBMS, and the components of the physical architecture of DBMS. So let's begin this session. Talking about the components of database management system, there are major four components of DBMS we have. So we have four components as data, hardware, software, and the user. So data comprises of various single user as well as multi-user systems that makes up a DBMS, right? So data stored in DBMS must include the two properties. First, it should be integrated, and second, it should be shared. That means we should have a connectivity among the values stored in a database. Then by integrated, it means that database should be a unification of several types of data or entities, or we can say files together that are distinct and have some kind of common attributes so that we can have a connectivity among them. Then it should be shared. By shared, it means that the individual pieces of data which can be shared among the several different users such that each user can have access to the same piece of data, or we can say different users can use them according to their need and they work on the same system. Then the next component is the hardware. Hardware consists of all the tangible portions that make up a database system or a machine on which we run a database management system. So hardware consists of various secondary storage devices because our main intention of creating a good database is to store large amounts of information. So for storing those information, we require hardware resources such as storage mechanisms. So we have secondary storage devices, we can use large servers, or we can use data centers to store the data. Now to get information from the users and also to give back the information to the users, we require various input and output devices along with a DBMS system. Then the software component. Software is a major part of a DBMS. It includes a layer of software that is in between the physical database and the user of the system, which acts as an interface between the user so that user can interact with that system and can finally access the data it is required. All the requests from the users for accessing the database are handled by the DBMS, and based upon the requirements of the user, the data is fetched accordingly. Then finally, we have the fourth component, which is the user. So they are those who interact with the DBMS for data processing and the retrieval of the desired information. The main aim of DBMS is to store the information. So to get the information back, we require users who will interact with DBMS to get the information. So we have three types of users, or three levels of users. First is the database administrators. They are the main users who create the database, right? They maintain the database and they are responsible for giving the access rights and other things to the users. Then we have application programmers and system analysts that manage or maintain the database properly. Then finally, we have the end users who actually use the database for their purpose of information gathering as well as information retrieval. Now we see the various types of DBMS we have. Broadly classified, we have distributed database, we have personal and user database, we have external databases, we have common operational databases, and we have common end user database. So common operational database includes all those databases that stored detailed information or detailed data needed to support the operational needs of an organization. It contains various kinds of information related to systems like production management, transaction management. All these kind of things require large amounts of data to be maintained. Such databases are called common operational databases. They are also known as subject area database, transaction database, and a production database. After this, we have common end user database. Here what happens, they take the data from the operational or the common operational databases and maintain it for different users for their different purposes. They are also called information or management databases. All your MIS, LMSs, they are all examples of common end user database. The next type of database we have is a distributed database. This database is very useful. Actually, what happens in distributed database is that here the database of local work groups or departments are integrated together so that you have a decentralized of information. You have some data kept at the branch office, some at the head office, some at the local office, and this way, with the connectivity of all these things, you have a common database which is maintained very efficiently at different levels. So this is distributed database. Then we have personal end user database. These databases consist of a variety of data files developed by users at their workstation. These are the files or databases that are maintained at the user end, at the user systems. And then we have external databases for storing other information or for storing the data for a longer duration of time. To reduce the load on the existing DBMS, we use external databases to store information, such as we have a data server, we have cloud-based systems to store the data. These comes under external databases. Then we have a text database. In text database, it is a type of a database in which there is a natural outgrowth of data and information by the use of computer in order to create and store documents electronically. For example, this is a kind of an electronic repository in which you need to store various files together, right? So such databases that primarily have textual data more are called the text databases. Now we come to architecture of database management system. Broadly speaking, DBMS are very complex and a very sophisticated softwares, so we have to understand the architecture behind creating the DBMS. There are two basic ways to look at the DBMS. First is a logical DBMS architecture. The second one is a physical DBMS architecture. By logical architecture, it means that it deals with the way data is stored and presented to the users. It is more of a user-centric approach towards designing a database. And physical DBMS architecture involves designing of software components that actually make up a database. So this is more internal level, and the first one is the external level architecture. So we have logical architecture and the physical architecture. Now we come to the logical DBMS architecture. This architecture describes how the data is perceived by the user, and it is not at all concerned with how data is handled actually. It is only concerned with how the data looks to the user. This is called the logical architecture. This is also known as ANSI Spark model, and a majority of commercial databases today and research databases use this framework. According to this architecture, the DBMS architecture is divided at three levels. First is the external level, second is the conceptual level, and the third one is the internal level. Let us now understand these things together. So, why there is a need of this three-layer architecture? The first important need is to separate each user's view of database from the way the database is physically represented. It means that based upon the type of users that are using this database, we have classified the different levels of access of this database to ensure the security as well as the consistency of the data stored in the database. It supports multiple user views. By using different views or at different levels, we can support multiple users and multiple views to the users of the same data. It also provides insulation between user programs and the data concerned with them. This is the brief architecture of it. We have three layers. First is called presentation tier or the presentation level, in which the external users are connected. Then we have the logical tier, and finally we have the data tier. At the presentation level, what happens? It is the topmost or the application layer of the DBMS. Here what happens? The main function of this is to create an interface so that the users or the external users can interact with the system. Second is the logical tier. Actually what happens here, we form the queries. We write queries to access the database. So this layer coordinates the application, processes commands, and make logical decisions required to fetch the desired data at the right time. It also moves the processes and the data between the surrounding layers. Here the last level is called data tier, or this is actually where the actual data is stored in a database and eventually to an external storage where the data is actually stored. For example, I want to get to know about the total of the sales made the last year. What happens? I just write a command here at the user. User only writes a command, get the sales total. So what does this sales total mean? That I have to get a list of all the sales made in a particular year or maybe last year. So what happens? Based upon the query received at this level, it will query the DBMS and finally fetch the data. Now what happens? Another user at the same time contacted this same DBMS, and that user wants to have a total of sales by adding all the sales of different quarters together into one unit. So what happens? We have to club. That means we have to add all sales together. Again, the query is made, this query is passed on to the DBMS. What it will do the work accordingly. It will add up all the sales 1, that is sales in the first quarter, second quarter, third and fourth quarter, and together it will give the combined answer that is required by this user. So in this way, this layered architecture helps to reduce the complexity as well as and gives a clear separation between different levels of users. The same architecture can be highlighted with this diagram. Here we have 3 levels of users. So we have external layout view for the end users, then you have the conceptual layer or the logical layer, and finally you have the physical layer. At this you have different views for different types of users. This is a normal users, which are end user. These are managers or administrators. So these are managers, and this is a specialized user called database administrator. All these 3 kinds of users access the same database, but based upon their requirement, their access rights, the view of the DBMS changes for different users. At this level, what happens? It actually is an interface layer. Then at the conceptual layer, we have a conceptual schema. In DBMS terms, schema means the design. So this is conceptual design in which we represent the actual physical representation in some kind of understandable form that is more appealing to the end users. Then finally, we have at the physical layer, we have the physical schema that describes how actually data is stored physically on the disk. So this is a clear distinction of the 3 layers according to this logical DBMS architecture. Now we come to the physical DBMS architecture. This physical DBMS architecture describes the software components used to enter as well as the process data, and how these software components are related and interconnected with each other. This database, in this model, what happens, the database system is partitioned into different modules that deals with each of the responsibilities of a DBMS system, right? So it is divided into storage manager and query processor. Storage manager is concerned with how the data is actually stored, and query processor is connected with how the query is processed and the data is fetched from the DBMS. Here, the storage manager is an important because DBMS typically requires a large amount of storage space, and query processor is important because it helps the DBMS system to simplify and facilitate the access of data. Query is basically a request to the system for fetching a data. So this is a physical DBMS architecture. Here we have 3 levels again. So this is for external levels. We have the application interfaces, we have application programs, we have the queries, we have a database schema. For normal users or naive users like tellers and agents, etc., we have a normal application interface through which they interact with this DBMS. Then we have application programmers that write routines for others to use. Then we have sophisticated users who write queries to fetch the data rather than by using the existing components. And then we have database administrators who use or maintain the DBMS schema, that is the design of whole DBMS system. Now, after this interface, we have a different layer, and this layer is a conceptual level layer. It is divided in query processor as well as the storage manager components. The storage management further divides into transaction manager, integrity manager, buffer manager, as well as the file manager. Then the query processor deals with the handling of the queries. So it has application programmers object code that is read. Then we have embedded DML compiler, that is data manipulation language, data manipulation language compiler, data definition language interpreter which interprets the language, and we have a query evaluation engine that finally evaluates a query and do the rest of the work, that is the fetching of the data from the store. Now using the storage manager, it accesses the disk storage to fetch the data. So you have data files, you have data dictionaries which contain information about data, or we can say that metadata. Then you have statistical data interface, and you have the indices or indexes through which it becomes very easy for us to fetch the data at the right time. Let us now briefly describe the different components of this. First is the storage manager. The storage manager is a program module that provides the interface between low-level data and the application program and queries submitted to the system. It is responsible for interaction with file manager. It translates the various DML commands and statements to work and find, and actually responsible for storing, retrieving and updating the data in the database. Its other components includes authorization integrity manager, transaction manager, file manager, buffer manager, storage manager, data file and data dictionaries. So all these are different components of this storage manager. Next component is the query processor. This query processor is an important part because it helps the DBMS system to simplify and facilitate the access to the data. This is very important because the primary intention of storing the data in a database is to fetch the information at the right time when desired. The other components of this query manager or query processor are DDL, that is Data Definition Language Interpreter, Data Manipulation Compiler. We have Data Manipulation Query Evaluation Engine that evaluates the query and take the steps further. So we have these three components of the query processor. Then finally we have, now based on the other functions, the DBMS system may be partitioned into further classifications, like we have DML Precompiler, that is Data Manipulation Language Compiler. We have Data Definition Language Compiler, which interprets the data definition languages. Then we have the file manager that manages the allocation of space or the disk space, establishes and maintains the list of structures like indices, etc. It can be implemented using an interface to existing file subsystem provided by the operating system of the host computer, or it includes a file subsystem of itself that can be written specially for this DBMS system. Let us now look back and see what we have covered in this module. We started with various components of DBMS. We have seen various types of database management systems. We have seen the architecture, both the physical as well as the logical DBMS architecture, and we have seen different components of these architecture as well. I hope this session is beneficial for you and it has given some insights into the architecture of DBMS to you. In the coming modules, I would be covering more topics related to DBMS. Till then, happy learning. Thank you.